Right, okay, so I'm talking about error intervals in this chapter 10. So what I'm proposing here is I'm going to do the first few even number questions, and then you guys, well, you should have read the examples before exercise 10A, and then you ought to do the odd numbered questions really, and what I'll do is post the answers to the odd numbered questions on a future video. So as I say, we're talking about error intervals, and we're trying to solve equations numerically. So these could be they normally are equations that you can't solve analytically, so you can't work the solution out. So what you're trying to do is get an answer that's as accurate as you need. So this equation here, f of x equals 3, add x squared, take away x cubed. So show that it's got an interval, and they're calling the interval show that it's got a root, and they're calling the root alpha in that interval 1.8, 1.9. So that means that the answer for alpha lies somewhere between 1.8 and 1.9. That's all it is, just like GCSE. So what you do is you work out f of 1.8 and you work out f of 1.9. So let's do that, like on our calculator. 3 add 1.8 squared, take away 1.8 cubed. Okay. 0.408. Okay. And then for 1.9, it's just going to change that. Well, minus anyway. Minus 0.249. So what we've got is, weird. What we've got it, well, that says 249. What we've got is one positive number and one negative number. So this graph, if we would imagine what the graph would look like, at some point it'd be positive, and at some point it'd be negative. So at some point it's above the x-axis, and at some point it's below the x-axis. So somewhere in the middle, it must be naught. That's the point. So what you say is, and you need to say this, you need to say this sentence. Bit covering it, like, but sorry. So there's a change of sign. That's the point. So it goes from positive to negative. Change of sign in the interval. And I'm using their notation. It doesn't say it in the book, but these square brackets mean less than or equal to. Right, so change of sign in the interval 1.8 to 1.9, and it doesn't say this in the book either, but you should jolly well write it. And f is continuous. I'll talk about that in a bit. Implies that the root is in the interval. Okay, right, and then that's it. That's the end of it. Okay, now let's do part B then. So part B, show that alpha equals 1.864 to 3 decimal places. So this time we need to come up with our own interval. So what interval is it that means alpha rounds to 1.864 to 3 decimal places? Just GCSE again. We're going to try. What is it? 1.8635. Yes. And 1.8645. Okay. Hopefully one of these is positive and one of them is negative. You should know which one's which, to be honest. You should be able to forecast it. Oh, what? 8645. 8645. There we go. Minus 0.0053. That'll do. And I'm just going to change them 4s to 3s. Okay. 0.0. Yes, go ahead. One positive, one negative. 0. Well, I'll write 1, 4. Same sentence, and you need to write it, and it's boring, but you do need to write it. So change of sign in interval 1.8635 to 1.8645, and f continuous, by which I mean it doesn't jump. There's no asymptote or anything. I'll show you one in a bit where it is like that. Implies, in this case, they were saying alpha, which is our root, is 1.864 to 3 decimal places. Right. Let's do number 4 on this same video. We've got to do it on the same paper, actually. What? Okay. When we fair the maths guys, I was doing one page, one question, but like, I'm running out of paper in the lockdown, innit? Okay, so this is a nice one. Notice it says it's weird. It's in radians, which is important. It should say that because we don't know what it is. Show that there's a root in the interval 2.2 to 2.3, so I'm going to work out f of 2.2, and I'm going to work out f of 2.3, and again, I'm presuming one of them will be positive, one of them will be negative, so sine 2.2, mine's in radians, minus log 2.2, be devastated if it weren't, 0.0200, okay, and then 2.3 now, right, there we go. Oh yes, minus 0.087. Okay, now I don't know that this is a continuous function, but it is. But like it'd be nice to see a graph to convince ourselves. But anyway, change of sign in the interval 2.2 to 2.3, and f continuous. Oh, I spelled that wrong there. Implies just a root in the interval, that'll do. Right, and let's do the same again there for part B, 2.219. Okay, so for part B, we want to work out f of 2.219, so 2.2185 and 2.2195. Let's work them out and hopefully see a change of sign. I'm sure we will. 2195, 2195. That's the negative one then, minus 0.0004, and if I change them 9s to an 8, slow on this, me. There we go. Oh yes, positive 0.0006, and again, change of sign in interval, and the interval is 2.2185 to 2.2195. That means, oh, and f continuous, yeah, only seen that because I looked at my previous example there, otherwise I would have forgot it. I'm not sure if you get marks deducted for forgetting that f continuous, but it's mathematically important, so it's good to write things mathematically correct, I think. 2.219 to 3 decimal places, and that's our answer. Right, okay, nice one.